On blackbody radiation and Planck radiation law. So we have seen what is a blackbody and the blackbody curve that represents a blackbody radiation. So this is a bell-shaped curve, and according to classical theories, we had two laws: Wien's law and Rayleigh-Jean's formula to explain the blackbody curve. And you can see here Rayleigh-Jean's formula: energy density is directly related to nu square, meaning that as frequency increases, energy density goes to a maximum, and that is represented by this term ultraviolet catastrophe, meaning that there is a breakdown indicating at higher frequency. So because of this formula, so there was a need for a new theory to explain this blackbody curve perfectly, and that originally led to the birth of quantum mechanics. So in the year 1900, Max Planck suggested a new framework because he had to make a revolutionary assumption in the basic framework, because the existing laws of classical physics could not explain the phenomenon of blackbody radiation. We had to remove blackbody radiation from the classical theory. And from a theoretical point of view, he said that oscillating charges are responsible for the absorption and emission of radiation from a black body, and a black body contains several such harmonic oscillators capable of vibrating at all possible frequencies. And this famous Planck's quantum hypothesis states that the emission and absorption of radiation by matter take place not in continuous steps but in discrete units or quanta of energy. Each quantum of energy is called a photon. So the energy of a photon is given by E is equal to n h nu, where n is an integer, h is the Planck's constant, that's a universal constant, and whose value is given by 6.626 into 10 power minus 34 joule second, and it has the same dimensions of angular momentum. Then nu is the frequency of the radiation. So according to this theory, the blackbody radiation energy of a blackbody radiation is only proportional or determined by the frequency of the concerned radiation, as given by E is equal to h nu. So this revolutionary concept was a break from the classical radiation. So we had to replace the continuous energy states by a discrete set of quantized states in the new theory. So absorption and emission take place not continuously but in discrete bundles. So let's consider this Planck radiation law in detail and try to partially derive the formula of Planck radiation law. So as we said, a continuum of energy state is replaced by the discrete set of states here, and this black body is a ensemble or a collection of quantum oscillators that absorb and emit energy in discrete amount. So let's assume that there are n number of oscillators. N number of oscillators in the system having total energy of that cavity be E. So total energy is E and N is the total number of oscillators. So we can write average energy will be E bar, will be given by the total energy divided by the total number of oscillators. Call it equation number 1. Now, what is this energy and what is this number? That is what we have to derive next. So let there be the number of oscillators, let it be given by n0, then n1. We have a total, n is the total number of oscillator. അതിനകത്ത് തന്നെ n0, n1, n2, n3, etc. nr. ഇത്ര എണ്ണമാണ് nr is the total number of oscillators എന്ന് എടുക്കാം. With energies, corresponding energy is n0 having an energy 0, then n1 is having an energy epsilon. So instead of E, we are taking epsilon here it stands for energy. Then N2 is having an energy 2 epsilon, N3 is having an energy 3 epsilon, etc. Nr will have an energy R epsilon correspondingly. Okay, so total number എന്ന് പറയുന്നത് അപ്പോൾ എന്തായിരിക്കും? It is a total of N0 plus N1 plus N2 plus etc. Nr. Let this be equation 2a. And what will be the total energy therefore? This will be the sum of all these energies. So 0 plus epsilon is the energy of the N1 oscillator. Okay, so total energy will be given by epsilon into N1 plus രണ്ടാമത്തെ ഓസിലേറ്റർ എന്ന് പറയുമ്പം 2 epsilon into N2 plus etc. R epsilon into Nr. Call it equation 2b. So we got an E as well as N. Okay, so total number of oscillator N is the sum of N0 plus N1 plus N2. It's a collection of oscillators. So, a black body എന്ന് പറയുന്നത് collection of oscillators ആണ്. So, it is sum of N0, N1, N2 up to the last oscillator. And its corresponding energy will be 0 plus epsilon N1 and so on. Now, this collection, this summation, we are replacing by the, we are using the Maxwell distribution formula here. So, according to Maxwell's distribution, total number Nr is given by N0 e raised to minus R epsilon by kT. That is the total number of oscillators. Nr is given by N0 e raised to minus R epsilon by kT. Therefore, from this law we can write N1 will be N0 e raised to R will be replaced by 1 here. So, e raised to minus epsilon by kT. Similarly, N2 you may write it as N0 e raised to minus 2 epsilon by kT. In a similar fashion, N3 will be N0 e raised to minus 3 epsilon by kT and so on. Therefore, we can substitute this back into equation 2a. Okay, so 2a was N0 plus N1 plus N2 and so on. So instead of that, we can write it as N0 plus N1 in pagaram endezhudam N0 e raised to minus epsilon by kT, this equation, plus N0 e raised to minus 2 epsilon by kT and so on till the last one, that is N0 e raised to minus R epsilon by kT. Okay, so this is actually a summation and you can see N0 is common. So let's take N0 out. So N is therefore given by N0 into 1 plus e raised to minus epsilon by kT plus e raised to minus 2 epsilon by kT plus etc. up to e raised to minus R epsilon by kT. So this represents a summation 1 plus x square plus so on. So that is given by this summation. So this part is given by the summation formula. Summation n running from 0 to infinity x raised to n, which is given by 1 by 1 minus x. Okay, so let's call this equation 3. And this formula, let it be equation 4. So we can substitute 4 back into 3. Okay, and write this expression as N0 into ഈ ബ്രാക്കറ്റിലുള്ള ടേമിന് പകരം നമുക്ക് ഈ സമ്മേഷൻ കൊടുക്കാം. സമ്മേഷൻ്റെ ഫൈനൽ ആൻസർ ഇസ് 1 by 1 minus x. സോ എക്സ് ഹിയർ സ്റ്റാൻഡ്സ് ഫോർ, എക്സ് എന്ന് പറയുന്നത് എന്താണ് ഇവിടെ, 1 e raised to minus epsilon by Kt is the x. Okay, so we can write n0 as n0 into 1 by 1 minus x. So into 1 by 1 minus x in pagaram e raised to minus epsilon by kt. So n is equal to n0 e raised to minus epsilon by kt is the formula that we get for the total number of oscillators after applying the Maxwell's distribution formula. Okay, so we got the total number of oscillators. ഇതുപോലെ തന്നെ നമ്മൾ അടുത്ത് എന്ത് കാണണം? എനർജിയുടെ ഫോർമുല കാണണം. So moving on to the energy, total energy can be obtained as E is given by equation 2b, that is E0 plus epsilon n1 plus 2 epsilon n2 and so on. അവിടെ നമ്മൾ n1നും n2നും ആണ് എന്ത് ചെയ്യാൻ പോകുന്നത്? സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാൻ പോകുന്നത്. So first is 0 plus epsilon into n0 e raised to minus epsilon by kt plus രണ്ടാമത്തത് 2 epsilon n0 e raised to minus 2 epsilon by kt and so on till r epsilon n0 e raised to minus epsilon by kt. Okay, again you can take something outside. എന്താണ് കോമൺ എന്നുള്ളത് നോക്കുക. e raised to minus epsilon by kt n0, that is common throughout. So sorry, n0 into, you can see epsilon is common in all terms and n0 is also common in all terms. So n0 epsilon you can take. Also you can see e raised to minus epsilon t. ഇവിടെയാണെങ്കിൽ e raised to minus 2 epsilon t, ഇവിടെയാണെങ്കിൽ e raised to minus 3, അങ്ങനെ പോകും. അപ്പോൾ e raised to minus epsilon by kt പുറത്തെടുക്കാവുന്നതാണ്. So this will be, first term will be 1, അതായത് ഇവിടെയുള്ള ഇവിടുന്ന് നമ്മൾ എന്ത് ചെയ്യുന്നു? ഇ റേസ് ടു മൈനസ് എപ്സിലോൺ ബൈ കെ ടിനെയാണ് പുറത്തെടുക്കുന്നത്. സോ യു ക്യാൻ സീ ഹിയർ ഇ റേസ് ടു മൈനസ് എപ്സിലോൺ ബൈ കെ ടി നമ്മൾ പുറത്തെടുത്തു. സോ വി ഗോട്ട് 1 ദെയർ, 1 പ്ലസ് ഇ റേസ് ടു രണ്ടാമത്തെ ടേമിൽ നിന്നും 2 ഉണ്ട് ഇവിടെ. അപ്പോൾ 2 ഇൻറ്റു ഇ റേസ് ടു മൈനസ് എപ്സിലോൺ ബൈ കെ ടി പ്ലസ് 3 e raised to minus 2 epsilon by kt and so on till the last term. So this is how we get the expression for energy, and this is also given by the summation n running from 1 to infinity n x raised to n minus 1. ഈ ബ്രാക്കറ്റിലുള്ള ടേമാണ്, ആൻഡ് ദാറ്റ് എക്സ്പ്രഷൻ ഇസ് ഗിവൺ ബൈ 1 by 1 minus x the whole square. So this ഈ ബ്രാക്കറ്റിനകത്തുള്ള എക്സ്പ്രഷൻ ഫോളോസ് ദിസ് സമ്മേഷൻ whose value is given by 1 by 1 minus x the whole square. അപ്പോൾ തിരിച്ചെന്ത് കൊടുക്കാം? ഈ ഒരു വാല്യൂവിനെ, ഈ കിട്ടിയ വാല്യൂവിനെ നമുക്ക് ഇവിടെ തിരിച്ച് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുന്നത്. Again x is given by e raised to minus epsilon by kt. Therefore we have e given by e is given by n0 into epsilon e raised to minus epsilon by kt. ഇത് നമ്മൾ ആദ്യമേ പുറത്തെടുത്താണ്. ബ്രാക്കറ്റിലുള്ള ടേമിൻ്റെ വാല്യൂ എന്ന് പറയുന്നത് 1 by 1 minus x the whole square. 1 minus x എന്ന് പറയുന്നത് e raised to minus epsilon by kt the whole square. Okay, so this is our expression now. Equation number, I think this was equation number 5 6. Okay, call it equation number 6 here. Okay, so we got an expression for both energy as well as number of oscillators n. So നമ്മൾ ആദ്യത്തെ first equation എന്ന് പറയുന്നത് we were trying to write the formula for E bar. E bar is the average energy which is given by E by n. അപ്പോൾ നമുക്കിപ്പം equation 6 ഉണ്ട് 5 ഉണ്ട് which gives the expression for energy as well as the number of oscillators. So let's substitute it here. So E is given by the expression n0 epsilon e raised to minus epsilon by kt divided by e term 1 minus e raised to minus epsilon by kt the whole square. Okay, അതാണ് എന്ത് expression. That's just the expression for, don't get confused, that's just the expression for energy alone. ഇത്രയും. ഇനി number of oscillators that is given by equation number 5. അതുമായിട്ട് divide ചെയ്യുവാണ് വേണ്ടത്. So that is given by equation 5 is n0 by 1 minus e raised to minus epsilon by t. So that will go up. So e raised to minus epsilon by kt. Now you can see that 1 minus e raised to minus epsilon by kt താഴെയുള്ളതും ഒരു term നമുക്ക് എന്ത് ചെയ്യാം? We may cancel one term here and one from the bottom. We can cancel n0 and n0. So we are left with the formula E bar is equal to this will be epsilon e raised to minus epsilon by kt divided by 1 minus e raised to minus epsilon by kt after the simplification. Now divide numerator and denominator by this term e raised to minus epsilon by kt നെ മുകളിലും താഴെയും കൂടെ നമ്മൾ ഡിവൈഡ് ചെയ്യാൻ പോവാണ് അടുത്തത്. സോ മുകളിൽ നിന്ന് ഡിവൈഡ് ചെയ്യുമ്പം that get cancel, epsilon മാത്രമേ ഉള്ളൂ. താഴെ ഡിവൈഡ് ചെയ്യുമ്പം 1 by e raised to minus epsilon by kt അതെന്താവും e raised to plus epsilon by kt ആവും. ആൻഡ് മൈനസ് ഇതിനെ ഡിവൈഡ് ചെയ്യുമ്പം e raised to minus epsilon by kt കൊണ്ട് തന്നെയാണ് നമ്മൾ ഡിവൈഡ് ചെയ്യുന്നത്. സോ മൈനസ് 1. Okay, so let me write it here for your information that we have divided the numerator as well as the denominator by e raised to minus epsilon by kt. Okay, on both numerator and denominator. Then you will get the expression e raised to so e bar is equal to epsilon by e raised to epsilon by kt minus 1. So we'll put this as equation number 7. So we got the average energy expression also. Now here is how Planck at this point of time Planck introduced his equation, that is energy is quantized and that is given by the formula E is equal to h nu. Okay, so instead of the Rayleigh-Jeans formula which used kT as the energy, here according to the Planck's law we are using energy, the formula for energy as h nu, that is the quantization of energy. So this expression for E bar will change it as, wherever you have epsilon, change it as h nu. So h nu divided by e raised to h nu by kt minus 1. So this is the expression for Planck energy, the average energy of the oscillator as obtained from the Planck formula. So call that equation number 8. Okay, so this let me stop here in this video. We'll stop here with the by obtaining the average energy of an oscillator. So hope it's clear. Thank you.